This is problem number 7 from section 5.6. This problem, they say, find the area of the region enclosed by the curves y equals sine x, or 7 sine x, and y equals sine 7x from 0 less than or equal to x, less than or equal to pi. So from 0 to pi. The first thing we've got to do, they kind of make this easy. They tell us our interval from 0 to pi. So we know that we're going to do the integral from 0 to pi. What we don't know, though, is going back to this function we've been, or this definition we've been using, is we don't know which function is larger than the other. Is it f of x minus g of x? Or like, is it 7 sine x minus sine 7x? Or is it the other way around? Here's how we can figure this out. If we plug in the endpoint 0, sine 0 gives you 1. And let's see, yeah, so sine 0, if we plug in 0 there, sine 0 is going to give you 0. And when you do sine 7 times 0, you also get sine of 0, which is 0. So at this point, if we look at a graph, and we call this spot 0, and out here this is spot pi, and this is pi over 2. Let's graph these functions. So they both start here, and when we plug in 0, that's what we get for both. But when we plug in pi, 7 or sine pi we know is also 0, and sine 7 pi, well, that's going to be also 0 as well, because that's going to be, if we go around 2 pi, 4 pi, 6 pi, 7 pi, we're on this axis, and we know sine is 0 at that point. So it's also going to be right here. So if we plug in the endpoints, we know we're meeting back on the x-axis. So the real question is, what happens at pi over 2 that's in between? If I have sine of pi over 2, sine of pi over 2 we know is 1. So that means 1 times 7, that means up here this is 7. So this is what, I'm going to point to this. This is what 7 sine x looks like. Okay? So then what if we plug in pi over 2 here? When we plug in pi over 2 here, we get 7 pi over 2. Well, we know 8 pi over 2 is 4 pi. So 8 pi over 2 is 4 pi, which would be right here. So 7 pi over 2, when we plug in pi over 2, is down here. Well, that's negative 1. So right down here, we know that this function is negative 1, and this is what this sine 7x looks like. So we want to find the area in here, but we now know that 7 sine x is the top function, and sine 7x is the bottom function. So we can write this now as f of x minus g of x. So we can say 7 sine x minus sine 7x dx. Okay. Now you're going to see me do something that you haven't seen, which is the properties of integrals. So we know that when we're doing derivatives, we can take the derivative and write d over dx in front of this one, then d over dx in front of this one. We can do the same thing with integrals. We can split the integral to just do the integration of just this point and just this point. So that's what you're going to see me do in this problem. And the reason for that is I want to do a u substitution here on this 7x, so I make sure that I get the derivative correct, or the antiderivative correct. So this is going to equal the integral from 0 to pi. I'm bringing the 7 out front, so it's 7, 0 pi sine x, minus the integral from 0 to pi of sine 7x. And this is, well, we'd have dx of this whole thing. So we can write little dx here and little dx here. Now I'm going to say u equals 7x. And over here, I'm going to just go ahead and evaluate. I know that when I do the antiderivative of just sine x, the antiderivative of sine x, if we look at, we know the antiderivative of negative sine x is cosine x, so the antiderivative of sine x will be negative cosine x. So this is going to give me 7 times negative cosine x, and we're evaluating this from 0 to pi. Minus, I'm going to do a u substitution over here. U equals 7x, so du over dx equals 7. So if we multiply dx and divide 7, we get du over 7 equals dx. So now we can write this as the integral from 0 to pi of sine u, and we replace dx with du over 7. So du over 7. I'm going to bring that out front, so I end up with 7. Well, I can just write that as negative 7 cosine x from 0 to pi. Minus, I bring a 1/7 out front, 1/7, integral 0 to pi sine u du. And that's going to equal negative sine cosine x from 0 to pi, right? Just writing the original one again. Minus 1/7. What's the integral of this sine u? Well, we know it's negative cosine. So that's minus that negative cosine u from 0 to pi. So then we can say that that is really just negative 7 cosine x from 0 to pi. And then we can plug back in u. We know u is 7x. So we can say minus, well, I'm going to actually, when I distribute this negative 1/7 to negative cosine, I get plus 1/7 cosine 2x, cosine 7x, my bad, 7x. And I'm evaluating this from 0 to pi. Okay, so let's do this one right here. This is negative 7 cosine pi minus negative 7 cosine 0. We plug those in. So just this little one. Plus, and we have 1/7 cosine 7 pi minus 1/7 cosine 7 times 0. Cosine of pi, I know cosine of pi is -1, so -1 times -7 is 7. This cosine of 0 is 1, and this is really just negative times a negative, which is a positive, so we're going to say plus 1. Or, sorry, plus 7. Right, that's negative 7, and that was a 1, so plus 7. 7 pi, we know 7 pi ends up over here, so cosine would be -1, so it's minus 1/7. And cosine of 0 is 1, so we end up with minus, so 1 here times negative 1/7 minus 1/7 there. That ends up giving you 14 minus 2/7, which if I take 14 times 7, I get 98. So I get 98 when I get a common denominator over 7 minus 2/7, which is 96 over 7. And that's the area between 7 sine x and sine 7x between 0 and pi.